Hello, we're back. And my colleague, my colleague Christian, somewhere there, he just came back from Romania, and obviously I told him before, when you come back, you have to bring me something. What do you think I got? Let me show you. A brand new book. This is a book on Romanian language. Pray for Chernobyl. So he knows about my little obsession with Chernobyl. And he gave me this book as a present. It's a brand new, it's sealed. Yeah. Svetlana Alexievich. Yeah. So probably this book is translated. And is saying the serial Chernobyl was inspired by this book. So I'll read this and I'll see how good it is. If it's the same with the movie. I was impressed, Bring me a book. Okay, let's fix something different today. What do we have today? We have a nice job. Wow, it's quite heavy. Audio amplifier. Yeah. The problem with this one, no power. Yeah. So we have to fix this. The speaker wire, so I suppose this amplifier probably died because the man short the wires. We have some black resistor, but I don't believe that are burned because we have center diodes here. So the resistors are used to lower the voltage, to limit the current. We have another burn resistor there, but I don't know what's the story with that one. So we have to fix this. We have 4 transistors here on the heatsink. 4, yeah. We have 2 transistors, like medium power there on the heatsink. Probably are the output of this transistor. It's going on the big ones. Possible to have a bridge amplifier, audio amplifier, or maybe not. The bridge, but it's easy to find if it's a bridged one or not. It's just enough to check the minus if it's going to the minus of the power supply. So the power supply, this is a dual differential voltage. Yes, so we have plus and minus and ground. Like how you can see here, you have the rectifier bridge, but the ground is this black wire, yeah, not the minus from the rectifier bridge. So we can check from this black wire to here to see if we have ground. So we will know if this is an amplifier and a bridge configuration or not. Diode, ground, minus, 0, 0 you can see on the multimeter. So it's not a bridged amplifier, it's a normal mono amplifier. Yeah. So I suppose the 2 transistors are on parallel mode and these 2 are on a parallel mode. That's what I believe from what I can see here. We have a relay. So let's do some checkings, yeah? Let me plug the cable, the power cable. Look at this transformer. This is a nice one. You see why I was looking to buy an audio amplifier for the power supply? Look on this one. So nice. And based on the wire size, yeah, I will say this is like 8, 9 amps. 7, 8 amps. I will say this transformer it is, yeah. So you see, this is a nice one. And all the audio transformers audio amplifiers, they have nice transformers inside, especially because they have to isolate the magnetic field from the board. You see, on this case, the people are using the heatsink on the middle just to keep away any interference, you know, any noises like 50 hertz noise. So it's plugged in, and let's switch on volts. Let's check first if we have any voltage here. You know, I love fixing audio amplifiers. Is like an open book for me. I done so many, like I build so many, and we will build on the future. On a video, we'll build audio amplifier. The power supply is just a start, yeah. So let's see, like how I said, the black is the ground. The black one which is coming from the transformer, and the rectifier bridge we have plus and minus. So let's see what we have here. Here you have minus, this is plus 46 volts, you can see on the multimeter, 46. And on the other one we have minus 46. And total, if you check, minus and plus of the rectifier bridge is 92 volts. Wow. 92 volts. Audio amplifier with 92 volts. Look on these big caps. 1000 micro each. So this amplifier is kind of, I don't know, I just guess like 150 watts. Just a guessing, you know. But it's nice. Okay, so what we can check here? We can check those resistors, you know, the burn ones, but that's normal, you know, because you can see you have here some channels. So they limit the current, and probably here it's a differential voltage for the preamplifier. But let's check. Nothing. 12. You see that? 12 volts? 12. And here 12. So everything is fine. Yeah, you can check straight on the resistors. It's the same thing. 12. And 12. We minus. Yeah. But because the plus is on the ground, so this here is plus 12. And here is minus 12. Okay. So these are fine. Nothing, no problems there. The burn resistor, 0 and 0. Okay, let's check the voltage on the big transistors. Collector, nothing. Collector, nothing. Collector, nothing. Collector, nothing. Okay, so we have no voltage there from some reason. No voltage. My amplifier doesn't have voltage. Can be this relay, but usually the protection on the audio amplifiers, it's a relay on the speaker, not on the amplifier. But we can see, it's just a start. This is just a start. Let's open the amplifier because we can't see anything like that. What we need to take out the heat sink. It's a nice job. It's, you know, and it's kind of well paid. So it's not important what kind of job we have on our audio amplifier, but always the price is the same. On our kit, £60, which is fine for, let's say, half an hour work, yeah. Because there's no way how it can be more than a half an hour. Maybe if you don't have the spares. We don't have the spares, but we can find quickly like a transistor, a resistor. We can find them quickly. Same like on the any other device, like laptops, like yeah, all the faults are on there where are high currents, high current, high voltage, so most likely you have a fault there. We'll see, we'll see. So I don't get it. These are inputs. Probably. Line in. I don't think can be outputs. No way. No, can't be output. Because there's nothing here to carry the audio sound here. This is just a shielded cable, probably for low signals. Okay, let's take this out. Let's see. Let's take this out. Now let's have a look. Oh, the transformer is heavy. Okay, let's open these things. Everything is big here, you know. You don't even need microscope. It's a pleasure to fix something like that. But you have to be careful, you know, it's 92 volts. It's a lot. You can even feel the current. 92 volts. So let's try and making up the schematics on our mind. I think that's all, yeah? Yes. Nice, nice, nice. Nice. This is the temperature, you know, the bias control. It's with this transistor. You have the rectifier bleach, plus and minus, plus and minus. That's plus. It's going here, here, here. That's the relay. So you see this here and this one here. So the relay is meant to make this. Now the question is, what is the condition for that relay to click and send the power? Because that's very important. If it's an error, it's a problem. Maybe it's a protection circuit. So let's see the relay. We have here the coil of the relay. One is going here to this transistor, this one. The other one, it's a resistor, which is fine. We have a Zener diode, which is fine again. I think we can check. Let's check. Diode. But usually the relay is not clicking. Whatever problem is there, it will not click. That's how the protection is made. No, it's not short. So all what we have to do, you have to follow the relay. Yeah, so you see you have this bridge, you have this transistor here. The transistor, I can bet, is fine. So one more time here. On this one, the base is on the middle. So that's the base. On the emitter, we have a resistor. We have a diode, okay. Diode is fine. From the diode, we have a resistor here. I just want to see from what is getting the protection, and I will show you after, yeah? Which is going here and here. Okay. So one thing, it takes information from this collector. I think I know. I think it's taking information from the output of the speaker. And if there is any voltage, probably will not start. But can't be voltage if it's not starting. Okay, that's, yeah, okay. Next, so this diode, and from here is going to another transistor here. This transistor is connected to ground here. And on the other pin we have a resistor here. This is a Darlington 2 transistors. Oh, you can't see, huh? You can see, like on the pins, so these are one transistor here, one here. You see these two are connected. This is a Darlington configuration. So from our base, no, emitter of this one, we have a diode here. No, sorry, the emitter is connected straight to the ground. Yes, that's the emitter. No, I was wrong. Okay, let's go with the base. Base. Here we have a resistor here to ground. Okay. And here we have another resistor which is coming here. It's on the output of this transistor. That's a capacitor, so here I should have some voltage. Okay. Let's see what is here. There is a resistor here, which is another transistor, and which is sending me on same point from here to here, and on the collector of this transistor. Let's check the transistors, yeah? Diode. Good. Good. Collector emitter, sorry, let's check collector emitter, yeah? Good. 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 It's okay, the transistors are good. Okay, let's try a trick. Yeah, let me get the power supply. Give me 1 second. Power supply. Let's see if we have any short. 30 volts. And I will try only plus and minus. Let's see. So this is minus, minus, and it's switching here. And this will be the minus, minus, okay. And plus here. Minus. Okay. Let's try a different way. Minus, 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 and plus on the median point. It's still 110 milliamps, which is a little bit too much for only 30 volts. Maybe not. And we minus here and plus here, here. And here is taking 430 milliamps. So the it's not taking the power. It's taking too much current. You know, I have 400 milliamps and I'm on 30 volts. Okay, let's try plus and minus here. And it's nothing. Between plus and minus is nothing wrong. Or because it's a long way. Okay, so our problem is here. Yeah? Minus plus, minus plus. Here is our problem. But it's not right the way how I'm testing this amplifier. Ay, 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 ay. But this is getting mad hot. Ay. This is okay, but that one is mad hot. Okay, let's see what's there. It's not short, because if it will be short, it will not get hot. Now, it can be a link, because here we have a burned resistor. You can see this one. It's not burned, it's hot. We don't know the size of that resistor. If it's hot, it's not burned. So probably it's at 22 ohms, because the other one is 22 ohms. Let's see ohm. Yeah, 23 ohms. You can see on the multimeter. So that resistor, which looks burned, is not burned. But from some reason, this transistor is getting very hot. It's taking too much power. $660,649. 649. What's this transistor? 649. Transistor. It's a PNP. PNP transistor. Nothing special, it's just a regular transistor. $180 volts. Collector emitter voltage 120. This is a A one, yeah? A, yeah. 160 volts, collector emitter voltage. Okay. 1.5 amps. That's nice. That's nice. Let's desolder. Because there's not really a way how to check the transistor in circuit, so we have to desolder 2 pins, yeah? Let's desolder 2 pins. Let's check now. Diode. No, sorry, this was getting hot. But don't worry, I will check them both, yeah? Okay, so that means that's base. Collect, this is emitter, collector, yeah? And collector emitter. Nothing. Nothing. I believe this is good. So the PNP one is good. That means the NPN one is not good. Let's check this one, which was getting hot. Let's check that one. So this is the base, collector emitter, good. Collector emitter, good. Base. Okay, and on the other side. Good. The transistors are good. The problem is I'm testing wrong, like the way how I'm testing. When you have a differential power supply, you can't test just applying one voltage. So whatever I'm doing wrong. You know what? I should stick with what I start, checking why that relay is not clicking. So let's get concentrated on that relay. Okay, this supposed to be here. Okay. So for the relay, in order to click, we need voltage first. So we have plus here. And minus on the ground. Let's try it. Let me solder the wire. Yeah, that's the median point. Minus. And plus is here. Okay. And plus is here. Good. So let's see if we short that transistor. If we short the transistor, the relay is clicking. Yes. It clicked once. It clicked once. It's not clicking. So it can be because the voltage is too low. Okay, let's go to 23 volts and use the plus straight here. It's clicking. You can hear? You can hear the relay clicking? So that's fine. Let's see base of the transistor in the collector is clicking. So the transistor is good. Thank you. Yeah? The transistor, so this is the base. And what the base is doing? No, that's not the base. Base. Yeah, it is. Base with collector. Okay, so this is the base. The base is going here, where it's a resistor, which is going to ground. Okay. Then it's going here, and here we have another resistor. Okay, we have a resistor from here. From here. Okay, this is not working because I'm using plus here. Should use the plus here. But the voltage is too low. You remember we have like 40 and something volts. Yeah, plus. Good. It's clicking here. So this is it's a full chain which is coming from this Darlington transistor here. So this is working. That's ground, it's okay. Good. And everything is coming from, what's the, let's see what's the, it's a resistor here, it's okay. Everything is connected with this. I need a close-up camera. So this is the transistor which is switching the relay. These are the relay things. Here we have a resistor to ground. The ground does mean the emitter of the transistor, but this is ground because it's going, you can see here is ground. This is ground, yeah? This is the ground from the transformer. So here is the base of the transistor. The base, we have a resistor here, you have a resistor here. Here is going to this Darlington configuration of these two transistors, 1, 2. You see are connected on Darlington. But the problem is the problem is the only connection from outside of this bubble is this. Here it's a capacitor, is this one, this point. This point is going here. This is a transistor. And the base of the transistor is coming from here, here. And it's going, no, from here, it's coming here. And from here is going to the collector of this big transistor. So somehow this is related. But I'm still not happy. If it's no voltage here, how this relay is working. I think I know how. I think I know how. No, I don't know how. Actually, I know how. It's supposed to be default to pass the current. Default, so without applying anything here, it's supposed to pass the current. You can see here, here and here, 0, 0. But not here and here, which is, you have two pairs of contacts. No here. No here. So actually the problem is very simple. It's the relay. So that's the coil of the relay. One pair of contacts here is passing the, yeah, they are stick, but not here. So actually the issue is the relay itself. And when it's an error, the transistor, it will click the relay to cut the voltage if it's a fault. What a waste of time. Okay. Let's take out the relay. The problem is on this one, it's quite dangerous to leave the audio amplifier without the relay. Because you know, you have 90 volts and it'll do like a big fireworks. If you want fireworks, yeah. But otherwise, we can fix the relay. If we can open the relay, we can fix it. Maybe. But otherwise, I don't have a relay here. Where is my weak wire? Funny, yeah? When you need something, you just get, okay, I found one. Let's get the relay out. I'm trying to get the solder out from the relay pins. Audio amplifier are nice. There is nothing digital, everything is analog, are nice. Everything with transistors. The problem is to fix something like that, you need a double power supply, which I don't have. But it's nice to have. Not all the amplifiers are like this, like with dual differential voltage, but most of them they are. Okay, the relay is out. So it's normal to be like that. This touch with this. This, no. This or this, it doesn't matter. Oh no, here. Here, 0, 0. And on this one, nothing. And the relay is one piece. Five amps. Maybe we can open this. The coil 24 volts. Yeah, we can open. We can open. We can fix this. We can do it. We can do it. Wow, it's melt. The relay is melt. Look at that. You can't see. I'll go under the microscope and I'll show you. This was a big spark. The problem is I don't know the reason, so it's very possible we are fixing the relay, and we will see some big sparks. Yeah. So you see the relay must be like this, like on this side. Yeah, you have two contacts. It's switching. Blah blah blah. Yeah. Look here. This pin is melted. It's just a bubble. You know what we can do? We can do something else. We can use these contacts. I think. I believe. I don't know. So when this is clicking, let's click it. Yeah. Yeah, okay, so it's clicking like that. It's clicking like that. Oh, I don't know how it's supposed to be. Let's try. Let's click the relay. It's not working. You can see it's clicking here inside, but it's not working. Probably because it's not moving. It's stuck. Stuck. So we need a relay. So it's not moving because it should be moving. Let's see one more time. I'm on this one. Yeah, it is clicking. You can see. It is clicking. You see, it's moving. Give me 1 second. Okay, so it is clicking. So the middle. You know what? I'm wrong. So that's the normal. You know what? Let's go under microscope. That's the normal relay position. If this is the normal relay position, yeah. Let me come with the power supply on the coil. So you see I'm clicking. But without applying the voltage, that's the position. That means we have these two pins together and this is alone, which is not the case with our board. You remember what we said on our board? Here is the relay, and we said, you know what? Without being voltage on the relay, we have these two. It's passing the current, but it's not. So actually the relay was stuck. You remember? Okay, you know what I mean. Yeah. Okay, so this pin we don't need, this is gone anyway. I don't know if you can take the pin out. Or maybe not. We have to take out. I'm thinking to move the pins from here, to move this one. And I think I can. Or that will be dodgy. To make this pin longer and touch here down somewhere. I think I can swap this one, which it doesn't need anyway, and swap it here. But the problem is, you see, this is it's not coming out. It's not meant to come out. No. Let's try and take this out. Good, you? Yeah, so we took out this pin. And I can move it here. Yeah, that's the burn one. And I put this here. Not really. Now will be fun. You know what I think? I think I will make this. And when we start the amplifier, we'll see like a big boom. Big spark. Yeah, it's inside. Oh. You know what, we can do it, we can do it. We can. Nothing can stop us. So what we have here, we have these pins here, this here. And this pin must be soldered there. Right? Right there. And we can solder the pin to create, make that pin to sit there in place. Yeah, we can do it. You remember I told you, you have just to carry on. Quitting, it's easy. Well, you learn from your own mistakes, you know? You learn. If this job come back, I knew it's dodgy. Next time I will not do it. Simple. Easy. That's the easy way to learn. But I think it's fine. There's no reason why this should come back. Okay. Let me see how the relay is clicking, because he has to touch our thingy. How dodgy it is this? We are just fixing a relay. Yeah, so let me show you under the microscope. I will stuck that pin with something else, probably hot glue. So what we done, that's the relay. Yeah. So we use this pin from this side, we move the pin on that side, and when the relay is clicking, you see it's touching the other thingy. Maybe I should put it straight to be like a perfect touch. Yeah. Perfect parallel touch, yeah? Yep. I know it's dodgy. If you'll come back, I'll buy a new relay. But actually there's no reason for this job to come back. If everything is on place here and the relay is clicking, only if it's blowing again. Perfect. Absolutely perfect. You know what? This explains why we found that resistor band. This explained because only one voltage was applied to the. No, for what? No. That explains a lot of things. Let's see if it's working. Let's click the relay. Plus 24 volts, okay. Oh, okay. Clicking. But how can I check? Yeah? Sorry? No, I can call. It's not there? Let me call. Give 1 second. Okay? Oh yeah, let's check. Let's see. Down mode, okay, let's see these ones. Let's click the relay. How can I click it? Yeah, and it's going to 0, okay. And here, it's not going to 0. Yeah, it's going to 0, you can see. So everything is fine. Now we'll plug in the amplifier. So it will be either a big explosion or will work. So what do you expect? Big explosion? Probably. This will be tricky. Okay. But I don't have the relay. If I will have the relay, I'll replace the relay. We don't have relay. We are fixing laptops here. Laptops, they don't have relays. Okay. 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 No, I will not plug it myself. I will ask Christian. Still 90 volts. You see in the relay it was melted. One pin was melted. Don't worry, I will ask my colleague. He is more brave. When you don't know what can happen, you are brave. The problem is I know what can happen. That's why I'm scared. Must be one more screw. We lost it? Probably. That's not good. That's not okay. It's too big. Okay, I have a problem. I need a screw. Oh. That's too big. Let me take this out. Let me find a screw. Let's see. Put this here. And
As it went through, listen, bro. I don't know why. It's multiple issues. But as soon as it went to 1 minute left, it added 20 more minutes. I disconnect the battery. 40 something. Goes down to 1 minute.
perfect. Let's check for short. Just to be sure it's nothing nothing wrong there. That's okay. Okay. I think we are ready. So let me find a brave one, a brave colleague. I think only this is okay, it's fine. How can I do it? Okay, you know what? Let me put 2 screws here. Only 2. And we'll see. That would be fun. One more. All done. Off. Off. Let's plug the cable. Good, and let's get someone to power up the. non di power acolo.
Oh, damn.
Hai posso
No.
Ah, no.
Oh, someone prendeze it?
No.
Fuck you then. You can press the power button. I'm not pressing no power button.
You?
You about to shock the fuck out of me. I'm not doing shit.
And the worst case will just blow.
Okay, then I'll watch. I'll record you.
Don't come and press the power switch.
Your birthday.
Yeah, do it. Yeah, it's your birthday. Yeah, yeah. You are brave, man. You have there. On off. It's on? Yeah, it's on. Yeah, looks like. Wow. So it's on. I have the power light. Let's check the voltage. Yeah. Let's check the voltage. Let's check the voltage. Volts. Ground. .46 volts on the big transistor, you can see there. So we have minus 46, and on the other, where should be? And plus 46, you can see on the other side. So everything is fine. How can we test it? I need a speaker. Give me 1 second, let me find a speaker, yeah? Yeah, we found one. We found one. It's a nice Kenwood speaker. Yeah, it's okay. Yeah. All good? Yeah.
Try and take the digitizer off.
Let's see. Let's see if we have voltage on the output. Just to be safe. We have no voltage on the output. Let me switch it off. Off. Okay. Power up. Yeah. Ah, the nice sound of the victory. So you can hear everything is fine. And the input. That's the sound of a working amplifier. Yeah? Okay. Nice. All done. All done. Now the question is if it will be fine. We'll see. There's no reason for that relay to die again. Because you know, it's not like two wires touching. It's that special metal there, bismuth, yeah, on the contact. So they should carry the current. Okay. Anyway, thank you for watching. Like and subscribe if you like the video. It was a long one. And see you on the next one. Yeah. Bye.